Hello everybody and welcome to the 24th webinar in the RUS series. My name is Georgia Karadimu and in this webinar we will learn how Sentinel data can contribute to geological mapping by classifying the different lithological units. We will talk a bit about the study area, Sentinel-1 and Sentinel-2, the RUS service, then we will continue to the exercise in the RUS virtual machine. We will have the take-home message and a Q&A session will follow. The webinar will last around 1.5 hours, and please be aware that this webinar is being recorded and you will be able to repeat the exercise by yourself later, since this recording will be available both in our YouTube channel and our training website. Please also note that it is advisable to start sending us your questions immediately as soon as you have one and throughout the webinar, since we're here with my colleagues to answer to as many of your questions as possible. This way, we will not have too many questions accumulated for the Q&A session. Now let's have a look to our study area, which is a part of the Anti-Atlas Mountains in Morocco. Here you can see the location of the area and in the center, the area that we will focus on. The Anti-Atlas Mountains of Morocco formed in the Paleozoic around 300 million years ago as a result of the collision of the African and Eurasian tectonic plates. This collision destroyed the Tethys Ocean. The layers of limestone, sandstone, claystone, and gypsum that formed the ocean bed were folded, crumbled, and created the Anti-Atlas Mountains. In this slide, we see a structural map of Morocco with a focus over Anti-Atlas Mountains, which has been published on 1982. In order to create it, there have been combined 6 geological, structural, and tectonic maps from 1952 to 1968. Here we have a picture of another study focusing on the stratigraphy of Anti-Atlas, where in pink we can see the cratonic basement, which is the oldest continental lithosphere, and the granitoid rocks. Now let's see quickly some information about the Sentinel-1 data we will use. In this exercise, we will be using SAR data provided by the Sentinel-1A satellite. The Sentinel satellites are included in the space component of the Copernicus program of the European Commission and the European Space Agency. The Sentinel-1 mission is formed by a constellation of 2 twin satellites phased at 180 degrees to each other. It is an active sensor working on C-band. It includes a right-looking active-phased array antenna, providing fast scanning in elevation and azimuth, and it provides data with a short repeat cycle of 6 days and with different imaging modes. Here you can see the 4 different acquisition modes, of which we will use the IW, and the 4 products of each mode, of which we will use GRD. Now let's move to Sentinel-2. For this exercise, we will also use multispectral data provided by the Sentinel-2B satellite. Sentinel-2 mission carries a passive sensor and is formed by a constellation of 2 satellites, Satellite-2A and 2B. They are passing at a polar orbit, phased at 180 degrees to each other, and the multispectral instrument it carries has 13 spectral bands: invisible, near-infrared, and short-wave infrared. The spatial resolution varies based on spectral band to 10 meters, 20 or 60 meters. At the equator, it has a revisit time of 5 days. Now let's continue to some information about RUS service. RUS stands for Research and User Support for Sentinel Core Products. It is an initiative funded by the European Commission and managed by ESA, with the objective to promote the uptake of Copernicus Sentinel data and support research and development activities. The service provides a free and open, scalable platform in a powerful computing environment, hosting a suite of open-source toolboxes pre-installed on virtual machines, which allow you to handle and process the data derived from the Sentinel satellites. What does this mean? Well, with the large amount of data produced by the Sentinel satellites, the challenge is no longer data availability, but rather storage and processing capacity. To solve that, RUS offers virtual machines so that you have the appropriate computing environment to handle the data. In addition to all that, RUS also provides a specialized user help desk to support your remote sensing activities with Sentinel data and a dedicated training program. You can find all the information about the project and how to register on our websites, so I recommend you to check them after the webinar to get familiar with the service and see the VM specifications, list of software, etc. I will quickly show them to you before we start the exercise. As I mentioned in the beginning, we also have a YouTube channel where you can find all the videos of our previous webinars, and you will also find this one in a couple of days. Okay, now let's move on for the exercise. First of all, I will explain you quickly the steps that we will follow. For Sentinel-2 image, first we will resample the data in order to have all the 13 spectral bands in the same spatial resolution. Then we will create the subset of the image we want because we don't want to process all the image. Then we will reproject it, because right now it is in UTM and we want it to convert it to longitude, latitude of WGS84. And then we will classify the product. We will try both unsupervised classification, where all the pixels will automatically go to a category the software thinks is better to belong, and then the supervised classification, where we will insert the vectors as training data, and the classification will be done after what we will define. Finally, we will export the products in GeoTIFF files in order to use them later in QGIS and also in KMZ files to be able to open them in Google Earth. Next, regarding the Sentinel-1 product, again we will create a subset which will have exactly the same coordinates of the Sentinel-2 image to keep the same extent. Then we will apply the orbit file, where we will get the accurate satellite position and velocity information. Next, we will remove the thermal noise, which is a background energy that is generated by the receiver and we don't want it in our image. Then we will calibrate it, because SAR calibration is meant to provide imagery in which the pixel values can be directly related to the radar backscatter of the scene. And then we will add the GEOL01 processor. This is the gray level co-occurrence matrix. This is a measure of the probability of occurrence of the gray levels, separated by a given distance in a given direction. It provides spatial information in the form of texture features, and there are some features we will show while we will process it. Those features are useful for the image classification. The next step will be to apply the speckle filtering. This way we will remove these salt and pepper-like textures of the image. Then we will apply the terrain correction, because the SAR data are converted from slant range to ground range geometry, and in a defined cartographic system we will select. Then we will subset again the image, because as you will see, the subset will be a bit bigger than the original we had applied with the Sentinel-2 image. It's the geographic coordinates used in Sentinel-2 in order to subset it and have exactly the same size. Again, we will apply the unsupervised classification and the supervised. We will select for the unsupervised in both images the k-means, and for the supervised we will select the random forest. And finally, again, we will export the data in order to be able to insert it in QGIS and on Google Earth and combine it with other data. Now let's have a quick look at the websites we have as service. This is our portal, where you can go and you can search in the menu the offer. We have the computing environments, and also here in the RUS library, learning by yourself. In the RUS lectures, you can find all our available tutorials. Here in our RUS training website, you can have a look in our future upcoming training events we have, and also find in the past trainings all the recorded videos with the Q&A document. Finally, as I mentioned, we have the YouTube channel where you can see all the videos, all the webinars that are uploaded a couple of days after the webinar. Okay, now let's go here to the portal. Let's log in with our account. And then we go to your dashboard. We click on, after this is loaded, we click on Access My Virtual Machine. And when you do that, you get redirected here in the RUS desktop, where you insert your credentials and you connect. We will now go here and we will click on this icon to have the full screen view mode. Okay, now that we are in full screen, let's have a look in our RUS virtual machine. Here you can see all the available software that are pre-installed. And first of all, what we need to start our exercise is to go and download the 2 images we're going to use. As you can see, I am already signed in the Copernicus Open Access Hub. I have just came here to this area over Morocco. I drew this polygon, this small one, and first I made a search about the Sentinel-2 mission. What we do? We go here on the left side, and in the sensing period we insert the date we want to download, which is the 14th September of 2019, both in the left field and the right field. Then we select the Sentinel-2 mission. In the product type we put Sentinel-2 MSI-2A, and then we click on search. Once we click on search, we can see that this image appears. So let's do it. Okay, and now here we can go and view here the product details and also click on download, and automatically the download of the product will start. Then we also want to find the Sentinel-1 image, so we go back again in the search menu, we deselect the Sentinel-2, we select the Sentinel-1 mission, and this time we want to find the product that was acquired on 8th of September, so we put in both dates 8 September. In the product type, we select GRD. In the sensor mode, we select IW, and then we click on search. And this is the image that corresponds over this area in this timing. Again, we can download the product. Okay, let's close that. We don't need that anymore. And let's start our exercise. First of all, what we need to do is to open our Snap software. We have created a folder where we have stored the 2 images that we have downloaded. And it is stored in the shared, in training, GEOL01 Lithological Classification Morocco tutorial kit in the original folder. Its tutorial kit contains an auxiliary data folder, an original, and a processing. In the original, we have those that we have downloaded. In the processing, all the outputs, and in the auxiliary, what we're gonna use for the webinar. First of all, let's load the Sentinel-2 image. We just drag it and drop it in the Product Explorer window, which is here on the left of the software. Here we can see that the image is loaded. And what we can do, we can go here on the left and extend the context and see the folders the image contains. Here, if you go to the bands, you can see that there are all the 13 spectral bands we mentioned before. And if we expand the masks, we can see here some other folders. If we expand this folder, the SCL, we can see that it contains information about the masks that have vegetation, that don't have vegetation, if there is water and if there are clouds, etc. The first thing I would like to do is to make sure that these images are downloaded. It has the least vegetation possible so that I can have the classification in the best way. So let's open this band, the vegetation band. We double click on it, and it is creating the image that will be viewed. As you can see here, there are those white pixels, those little white pixels that correspond to vegetation. That means that the area we selected is quite good for classification, for this type of classification we want. You can also open the cloud masks to see if there are clouds over the area. But now we will not insist more on that. We will close this one. And the first thing I would like to do is to create an RGB image of the product to visualize it and locate it on the Earth. So what we do is we right-click, we go to Open RGB Image window, and here in the profile there are some options. We would like first to open an RGB image where in the colors we use the B4, B3 and B2 bands in order to have the natural colors. So we just click OK and the image is being created. Okay, here we have our image. We can go in the world map and zoom in and see that it is located exactly over the anti-atlas area we selected. Good, this is our picture, but do we need to process all this picture? No, we don't need to do that. So what we only need to do is to create a subset and define a small area we would like to process. How do we do that? In order to be able to subset the area we want, first we need, as we said before, we need to resample the data so that they all have the same spatial resolution and reproject it. So the first step we do is the resampling, which we go to Optical, Geometric, S2 Resampling Processor. We can see that in the source product we have the Sentinel-2 image, and here down in the target product the S2 resampled suffix has been added. But we don't need to keep all these names, so we just delete the parts we don't need, and what we're gonna only keep, for example, is gonna be Sentinel-2B and the date of the product. Here in the directory I have already set the processing folder in our tutorial kit. If you click here in these dots, you can select the path you want, the folder you want to store it. In the processing parameters now, in the output resolution, we will select 10 because it is the one from the B4, 3 and 2 that we are using for the natural color. You can select the 20 if you want, it will be a bit faster than the 10. For the upsampling method, we select nearest. You can also leave the default one. We leave the rest as they are and we click Run. I'm not going to run it now because I want to save some time. I have everything pre-processed, so I'm just going to load the result of that. I go in the processing folder and I load here the resampled image. Okay, now that we have the image resampled, we can create the subset we want. How do we do that? First, we select the product we want to subset and we go to raster subset. It is creating. Okay, so here we have in the pixel coordinates, we will select one by one, and in the scene start X, I will put 1, 5, 2, 3. For the Y, I will put 3, 8, 7, 5. For the next one, I will put 6, 6, 5, 6, and the last one 9, 4, 2, 6. Okay, now you can see that here on the left this shape has been formed, and this is the subset area we're gonna work on. You can make it smaller or bigger depending on your interest. I just want you to remember that here, go to the GeoCoordinates tab, write down these numbers because we will use it later for the second subset part of the Sentinel-1 image. Just keep it in mind. Okay, so here you just click OK and you run it, and it's immediately being created here on the left. But here this name we have, it's subset 0 of the product. We don't want to keep it like that, so what we do is we go here, we right click on the product, we select Save Product, it says us that it will need to convert it into beam dipmat format. We click yes. We go here, we define the folder we want, and we also define the name we want. So this one, I'm just gonna name it subset, and I keep the rest of the name as it is. I have already pre-processed it, so I'm not clicking save now because it will override the previous one. I just click cancel. So I go here, I close this product. I don't want to save it now because I have already done it before. And I just load the subset that is resampled. And here it is. Now what we can do is we can go here, right click, and create again an RGB image window in natural colors using the bands 4, 3 and 2. Click OK. And here you see the subset we have created. Great. Now the next step, before we are able to classify, first we need to reproject the picture, this image, because it is in UTM. So we just select it here, we go to raster, geometric operations, reprojection. Okay, you see here in the name, in the source product, we have this subset. The reprojected suffix is being added in the target product. We have the directory we defined before. And in the reprojection parameters, we leave them as they are by default, and we click run. So the result we're gonna get from that after the reprojection, it is this one, for which we will go again and we will create an RGB image window of natural colors. Let me close the first view. Okay, so now this is created. We can close all the previous views, we don't need them anymore. And it's time now to go for the classification. First of all, we will try the unsupervised one, which, as we said, it's going to classify all the pixels in random classes. So in order to do that, we go here, we select the product, we go to raster, classification, unsupervised, and we select the k-means cluster analysis, which according to that, it is selecting a k number of pixels whose samples define the initial cluster context. So what do we do? As a source product, we insert the product which is reprojected, and you can see that in the naming the k-means has been added. In the processing parameters now, we leave the default number of clusters 14. You can select it to put more or less, it's up to you. The number of iteration is 30, which means that after it will check 30 times all the pixels and tries to classify it. After this number is reached, it will just stop classifying, and this will be the final result. And for the source band names, from all the bands available, we will select only the B2, 3 and 4 in order to make it a bit faster. The more bands you select, the more time it takes. So this one, we just run it. I'm not gonna run it now. And the result we get from this analysis, it is this one. I'm having this product, I expand it, and in the bands, I see the class indices. I double click on it. And here we can see the classification. We can zoom in and zoom out a bit so that these pixels will become more clear. This is a quite good, let's say, classification that if I open again the reprojected image before the classification and I put them the one next to the other, we will see that it quite well corresponds to reality. Of course, this scale doesn't really help us, so what you really need to do is to really zoom in a small area in order to be able to see details. This was the result of the unsupervised classification. Now let's go to the supervised one. In order to do that, we need some training data. So first of all, the product we will classify, it is this one, the reprojected one. What we're going to do is we're going to expand it, and we're going to expand the vector data. You can see what it contains so far. We are going to import by going to vector, import ESRI shapefile. We are going to go to our auxiliary data, go to the geology of Morocco, and select and load all the options that have a number in front of them, apart from the final geology, and just click Open. When we click Open, here for the mask layer naming, we will select the code description 1, and then we will click No, so that all the polygons that belong to the same shapefile will open at once and not in different categories. Just be a bit patient because this takes some time just to do it for all the layers. To select the proper layer and then click No. And you can see that they start to appear on the background on the image we have. Okay. Great. So all of them now are loaded. As you can see on the left, we have different information about the age of the rocks we have, of the sedimentary rocks, and also we have the condition if they are continental, fluvial, etc. What we need to do now, we need to create the training data. For that reason, for each category, we are going to create, by going here to the vector, new vector data container, we're going to create a new vector data that will appear here on the left. And we will go and we will use this tool, this polygon, and we will draw a small area that will be used as the training data and will correspond to this one. This takes some time, and this is the most important step because it is what you need to do very well in order to have the result, the good result of your classification. So I have done this before for you, so I'm not going to create now the training data, but here if I go to vector, I can import the SRI shapefiles that I have saved, and they are here named geometry, and they have the numbering that corresponds here to the names we have on the left. So I'm going to load all of them. I select them and I click Open. And here the only option you have is the style CSS, which is the naming. It is being saved when you create a vector container. So we just select No here to all of them. And you can see that the training data, the vectors start to appear behind this window here. So I don't need any more this image, I just close it. So this is how we created the training data. Now the next step we're gonna do is that we are gonna go to the raster classification supervised random forest classifier. We have talked about it in our previous webinars as well, about this classifier. If you have any questions, feel free to ask. So here let's load first all the products we have on the Product Explorer window, but we will only keep the reprojected one that we want to classify. So we select the other four and we remove them. We move to the random forest classifier one. Here in the new classifier, we name it new classifier Sentinel-2. Sentinel-2. We select train on vectors. We have the evaluate classifier selected. And for the training vectors, what we want to select, we leave here the number of training samples and trees as it is. You can reduce it if you want to 500 to 1000, because after a while it doesn't matter. The more you have, it doesn't improve, it doesn't contribute to the improvement of the result at all. So in the training vectors, we go here and from all those, we select only the geometry polygons we have created. To the right, if we go, we can see that the RF random forest is being added, and we click Run. Okay, let me load now the result that we had before. So from this processing, this is the result we get. Okay. If I open it, the labeled classes, it is this one. Let me close the previous view to have only this one. Okay, so you can see how the result looks like. What we can do is we can open again the one from the k-means and compare it. We can go to Window, Tile horizontally, and see the differences. When you zoom in and zoom out, you have a more clear view. You can navigate and see the details. So here, this is the result we have on the left from the unsupervised classification, and here on the right, what we have with the data we selected. So we will just remember that when you do this processing, the new classifier TXT file that is being created here, it is giving you some useful information about the number of classes you have used and also the accuracy of each class separately, and other more other information that are useful if you know how to interpret them. Okay, now this was all the processing for Sentinel-2. What you can do now is you can export the images you want. If you want to export any of them for visualization in Google Earth, you just right-click on the image you have opened, you go to the Export View as Google Earth KMZ, and once you do that, you select the name you want. You can name it as you want, you select the path, and you save it. If you now want to save, for example, let's go to the reprojected one, and let's say that we want to create a GeoTIFF to import it in QGIS. This you can do it with everything. I will just show you an example. I select the product, I go to Export GeoTIFF, and from this one, I want to export in the band subset only the B2, B3, and B4 bands, because these are the three bands that we use for the natural colors. So I go back again to the spatial subset. I don't change anything because I want all of it. I click OK. And here you see down that there is a name. You can select the name you want to put in the output product. And that's how you export it. If you just want to export, for example, the result of the random forest, you select it, you go to File, Export, GeoTIFF, and you just click Export Product. You don't need to do anything else. Okay, so that's all. We're gonna close Snap and we're gonna open it again to continue with the processing of Sentinel-1. Whatever it says, if you want to save it, just click No. And let's open Snap again to continue with our classification. So first of all, we have the Sentinel-1 picture, the Sentinel-1 image. Let's load it. This is on radar. And for this one, I'm gonna expand it and I'm gonna open, for example, the intensity VH. So this is the result we get from this band. Now, we don't need to process the whole image, we need to process only a small subset of that. But now, in this case, because we need to apply a few more steps, we will not do them one by one because this will occupy a lot of storage space. For this reason, we will create a graph, we will build a graph with all the parameters where you will define what you need for the pre-processing in order to have the product ready for the classification. So we go here to Tools, Graph Builder. I will quickly give you some information about how this works. First of all, when you open it, you have two operators, the read and the write one. Just remember to right-click and delete the write operator, so you have only the read. Here on the lower part, you see that there is a tab which has the same name corresponding to this operator. As a source product, we're going to put the Sentinel-1 images. I'm not going to build now the graph because it will take us a lot of time. I have already prepared it for you. I will just show you that by right-clicking here, you can go to Add, you can navigate to all the menus, and you can insert the processor you want. For example, the first thing we will do here will be to create a subset. So if I want to add it, I will go to Add, Raster, Geometric Subset. I will click on it. It will appear here. And then you will see that another tab will appear down here. And in order to connect them, you go to the previous one, you drag the red arrow, and there you go, they are connected. And here down you can see that all the information has been appeared for the subset product. I'm not going to build the graph now, I will just load the one I had before, I had created. I have named it Processing Graph Sentinel-1. Okay, and here it is, the graph. Let's go to the tabs very quickly, one by one. As I mentioned in the beginning, these are the processing steps. So we have the read operator that contains the product, and in the subset we want, first we go and we select all the source bands. Then we go down here, by default it is on pixel coordinates, but we go to the geographic coordinates. And here there is a text, this polygon, which corresponds to the exact extent of the Sentinel-2 product. We took the geometry of the Sentinel-2 product, we copy it here, we click Update, and when you zoom in, you see that here with the yellow is the small area that we want to subset. Then we want to apply the orbit file. Here we just select Do Not Fail if new orbit file is not found, because these are available a few days after the product is being created. So in case you're working with a product that is very freshly released, they might have not been published yet. In thermal noise removal, we have to check that the remove thermal noise is selected. We will do it in both polarizations. For the calibration, again, we want this output. For this processor, we see that the source band that has to do with the texture, the source bands are both with the VH and the VV polarization. You can define the window size. The smaller it is, the more time it takes. We will keep here all the default options. If you have more questions about each processor, just remember that up here there is this snap help option that you can write, and you can search what you need, and it can give you information about what the processor is doing and the parameters. In the angle, we will not select a specific one. We will ask it to do the processing based in all angles. We leave everything as it is, and here you can see the features that are available. The more features you select, the more time it takes to process. Here we will use only the contrast, homogeneity, and the GLCM min options. I will show you later why, but if you don't know which ones are those that you really need, just let it run on all of them, and then you can select based also on the application you want and the result they give. So here let's leave everything by default. In the speckle filter, again, here you see all the source bands. Whatever you have selected in the previous processor, we have these 2, 4, 6, 8, 10 options. So in the speckle filter, in the bands, we have 20 outputs because they correspond both for the VH and the VV polarizations. We will keep it simple. We will use the Lee Sigma filter. More about the filters you can find at the end of the tutorial in the literature and also in the snap help if you want. The window size, the target window size, we will leave everything by default. And then in the terrain correction, we will select the SRTM 1 second. If you want it to be faster, you can select the SRTM 3 second. In the resampling method, let's keep the bilinear interpolation. You can always move to nearest or bicubic or whatever you want. We leave all the other parameters as they are. It will terrain correct it to WGS84. And finally, we will write this output. You see here that the orb, NR, CAL, GLCM, SPK, and TC suffixes are being added. From all this chain, the final product that will be stored will be here on the right, and it will contain the information of all of them. If we process each step separately, this means that we will have 6-7 more products that will occupy space in our storage disk. Once you have the graph created, you just go here to save. You give it the name you want and you save it. And you run it. And the result of that, I will show you immediately which one it is. Okay. It is this one. Okay. And if we go here and we open the bands, we can close the previous view. I would like to open only the contrast, the homogeneity, and the GLCM mean of both polarizations. So I just double click on them. You can open more if you want, and more if you want more information, you can navigate and see what each one is offering. So I'm gonna just click on window tile evenly, and now I have on the upper part all the VH polarization, the 3 features that correspond to the VH, and below on the VV. If you play a bit and zoom in and zoom out, you will see the advantages of this and disadvantages of each one of what you want. So this is the first step, the first processing part. We will now, we want to continue with the classification, but as you see here, this extent of this image, it doesn't really correspond to the real one of the Sentinel-2. It is a bit bigger here on the left side and on the right side, and also on the top and the bottom, it is a bit bigger. So before we continue to anything else, we will continue to subset again. So we will select the product, we will go to raster, subset. And if you remember that I told you before, we will go to the geo coordinates, and here we will insert the geo coordinates we had from the Sentinel-2. Once you do it and you click OK, the product is being created, and you can name it as you want. In this case, I have named it a final subset, and I'm gonna load it right here. So here it is. From all those bands that remember the contrast, the homogeneity, and the GLCM mean that we will use for the first part of the unsupervised classification as bands, I will just keep now only the VV homogeneity. And I will open from the final subset the same band. I will put them horizontally. And here you can see that now the band on the right side is similar and has the same extent like the Sentinel-2 image. Okay, we don't need any more of those views, we can close them. Let's continue now with the classification. As I said, first we will apply the unsupervised exactly as we did before. We select the product, we go to raster, classification, unsupervised, k-means. We make sure that this is the one selected, and here in the processing parameters we leave again the number of clusters as it is, and in the source band names we select the contrast, the homogeneity, and the GLCM value of both polarizations. And we click Run. Okay, this is the one part, but As we said before, we consider that for the rock type classification, very good results could be achieved by classifying based on the band VV homogeneity. So if I run that with these 6 bands I have selected, this is the result I get. With the k-means. Let me open it. This is the result I get. And if I do a second classification by selecting only the VV homogeneity band, which I will change it, I will put the corresponding naming at the end. I named it VV home. And I open it as well. We can put them horizontally and see the differences. So here on the left, we have the classification, the unsupervised one, as it happened by the software itself. And if we go, for example, in the first one, and we go in the color manipulation, we can see here the values of the labels and the frequency. This you can do it for all the outputs. If you also go on the second product, okay, and now, again, now that we have this result, you can try to classify it based on any band you consider more appropriate. But now we will go, as we said, again, to the supervised classification. We don't need any more these views. But as we said, remember that the classification will be done here in the product, which is the final subset that is already terrain corrected. So again, we do the same procedure we did before. Let me open here the VV homogeneity one, because this is the one we're going to use. Remember that you go to vector and you import the training data we have created. You can also create a different set of training data based on this one if you want. And you can see that the polygons start to appear. The more detailed the creation of the training data, the better the results are. So now that we have them here, we go again to raster, classification, supervised, random forest classifier. Again, we add all the products, but we don't need all of them. We only need the one. This is to make it faster. So we remove the previous ones. In the random forest, we name the new classifier Sentinel-1. Again, we keep the same options. As training vectors, these are the vectors we have because we didn't load anything else. We select all of them. And down here, for the feature bands, we select only the VH homogeneity. Only this one, the VV homogeneity. Now we go to write, and it has the suffix RF. We run it, and the result we're going to have, let me close those. The result we will have, it is this one, a random forest. Let's open it, okay. But we can see here what are the results. Let's compare it with the unsupervised one. Let's put them in parallel. So here we see, based on the texture, on the pixels and the values they had, what happened on the left part, which is the unsupervised, and what is the one we used for the with the training data on the right. If you open the TXT file of the classification, you can see that the accuracy is quite good. Is not as good as it was before for the Sentinel-2. That means that you probably need to select again a different training data set. But this is the result. I mean, it gives us a very good idea that could correspond very well to reality, but right now it shows that the best result from when classifying Sentinel-1 goes to the unsupervised classification if you select the proper band, and if you want to do the supervised one, you need to very well and carefully select the training data you're going to use. As we said before, again, you go here, you select each band you want to export, you go to File, Export, GeoTIFF, and you just export it and store it where you want. So this was the first part with the snap. Now we're going to quickly go to open QGIS, where we will add all this information, and we will talk a bit about it and see finally how Sentinel-2 and Sentinel-1 can contribute to classification. Okay, the first thing I'm going to do, I'm going to go to Web, Open Layers plugin, Bing Maps, Bing Aerial. And here we have a base map to put all our products. What I'm going to do next, I'm going to go here in the processing file that I have already saved the outputs I want, and I'm going to load all the geotiffs I need. First of all, I will start with this one, which is the natural colors of the Sentinel-2. Then I will continue with the k-means result I have from Sentinel-2. Then also I will add the random forest. And now let's move to the Sentinel-1. I will add the k-means, the geotiff file. I will add the k-means we applied based only on the VV homogeneity band. And finally, I will add the TIFF of the random forest that was based on the VV homogeneity band. Okay, let's deselect them all, apart from the first one, that is the Sentinel-2. We go right-click and we go Zoom to Layer. And here we see where it is located. Okay, now what we see here are the different rocks, the different types of rocks. Let's import something else that we need. So let's go to the auxiliary data we have, and let's go in the geology Morocco and add the shape file that says final geology. Let's add it. Okay, here you can see that these polygons have appeared. What are we gonna do? We're gonna go here, right click, properties. First of all, we will select here on the style categorized. As column, we will select the code -1 as we did when we were importing the vector files. Random colors, we will click classify, and here you have the 14 classes of the different types we have of polygons, of different categories. And we just go here in the layer transparency, we increase it to 50. We click OK. And here you can see how it is overlaid on the top of the subset of Sentinel-2. We can play a bit with that. We can select and deselect it to see how well it corresponds to the results. So let's go one by one to see the subsets we have. Let's deselect the first one. Let's load now. Okay, let me put that on the top to make it easier. Okay, let's move now to the classification, to the result of the classification we had from the unsupervised classification. If I import and remove all the time this shapefile, you can see the accuracy and how quite well we have results that it has classified our shapefiles. If now I continue to the one we have with to the one we have that was the supervised one, based on the vectors we trained. Here you can see again, although the colors don't look too clear, but if you zoom in the area you want, here you can see again how it looks like. Okay, let's move to the next one. For the Sentinel-1 now, that we used for the first one, we used the 6 bands. This is the result. You can see that it corresponds quite well. Some limits are not very clear, but if you zoom in, for example, you might be able to recognize some differences in the colors. Don't forget that this also depends on what you have as training data. Let's continue to the one we did only with the homogeneity, which seems to be, in terms of Sentinel-1, the best one. It goes very well with what we have. And finally, the supervised classification we did, that if you check, it kind of goes well. It's not the best result because for sure we need to improve our training data. So that was all combining the geological information we had from the shape files. The more shape files you have, the more accurate you can become if you classify very carefully the images by importing the proper training data. It is important to have an overview of what is happening in the area. The list of vegetation possible in the area helps a lot when working with Sentinel-2, and also if the area has no clouds, it's better. In the areas that we have vegetation, we can always, not too big vegetation, we can always use the Sentinel-1 images. Here you can either select which one you want to use of all these features you can have, or you can see the combined result based on the availability of your data. The last part I'm going to quickly show you, because this was the exercise. I will show you how to download the data from the virtual machine. You just go to your keyboard and you select Ctrl, Alt and Shift. And this is the window that appears. So you go here in Devices, in Home RUS, you try to find what is the path you have stored your data. So here it is, and in the processing. And for example, I want now to download all the KMZ options I saved to visualize them in Google Earth. Unfortunately, Google Earth is not supported in the virtual machines. So you need to download it and open it in your computer. When I double click on it, it automatically starts to download it. So I close it again. Okay, now we are opening here the Google Earth. We are opening here the Google Earth. And we click here on the RGB image we have exported before over this area. And here we see how it looks like. Okay. Apart from that, we can deselect it and we can see the result of the unsupervised classification we had with Sentinel-2. Now that you have this background here, you can see also on the left the classes. Of course, you can play here with the transparency as well if you want. It's exactly the same like in QGIS, but in QGIS you have the advantage of combining with other shape files, with other information, these outputs, while here you can only visualize it. Here you can see that if you remove it and put it back, the classification, the unsupervised classification based on the Sentinel-2 image corresponds quite well to reality. Now let's continue with the result of the supervised classification of Sentinel-2, with the training data we created. Here you see again the classes. So here you see that the classification is not bad at all. It corresponds quite well to what we have. Although it was not so obvious before in QGIS, here you can see how they correspond quite well up to the whole details we have. Let's continue now with the unsupervised classification we had for Sentinel-1 with the 6 bands, which you see that it's not the best result as we saw before. But if we continue now to the classification, the unsupervised one we had based only in the homogeneity of the rocks we had, you can see that the results look much better and more close to reality. If you select and deselect it, you can see that it corresponds quite well. Now the differences on the backscatter we had or on the radar images, they can be due to different parameters, due to the angle, due to the fact, due to which is the orbit, if it is the path, if it is ascending or descending. But these are more detailed parameters which you can go into detail once you become a bit more advanced on the topic. And finally, let's see the supervised classification we had with Sentinel-1 based on the training data, which was not showing to be very good to be used before. But now, if you can see, the major features can be seen quite well and the results are quite satisfying. Okay, so I hope you learned something new today. This was the part regarding how to process Sentinel-1 and Sentinel-2 images in order to reach up to the classification step. What are the advantages and disadvantages of unsupervised and supervised? In the supervised, you need to have a very good training dataset, which means you need to know how to select the proper data, and you should better have different training data for the Sentinel-1 and different for the Sentinel-2 based on the characteristics, while in the unsupervised it is reading all the pixels of the image and it classifies all of them and it distributes them in the best way it can in the classes you have defined. Remember this information about how many classes you select and which are the parameters you insert, of course, depending on the area you want to process. Of course, depending on the area you want to process, you can always have different parameters and adjust your methodology and improve it based on what you want to do. Now let's continue with the take-home message before we continue to the Q&A session. With the new Sentinel satellites, the challenge in satellite remote sensing is no longer data availability, but rather how to store and process all this information. In addition to that, it is necessary to explain how the data can be used and support users in their applications. The RUS service is here to solve those problems by providing virtual machines to store and process the data and by offering a dedicated help desk supported by a team of remote sensing experts to help you in your projects with Sentinel data. So, before moving to the Q&A session, let me tell you again that you can repeat this exercise by your own if you want to practice or adapt the methodology to your own application. For that, go to rus-copernicus.eu, register in RUS and apply for a virtual machine. During that process, you just need to specify the training code GEOL01. You will receive the training kit that contains the PDF of the step-by-step guide and the auxiliary data. Also, you can always find these step-by-step guides in our RUS portal under the RUS Lectures tab. So this was all from my side. Thank you very much, and I will give you a couple of minutes to post your questions and I will be back to you for the Q&A session. Okay. Thank you very much. Just to let you know before we close that you can answer in our survey we have after we finish this webinar, and you can always write your comments for improvements and your questions and contact us for anything else you need. Thank you very much and have a nice day.